Hey, in this video we're going to talk about reducing radicals and simplifying radicals down, and I'm going to start with some basic examples and then we'll work on up. So let's start with the square root of 40. We typically would not leave this radical written this way. There is another way to write it. And this involves looking at the list of perfect squares. So I'm going to pick a number and then I'm going to write it squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and again we can continue this list, but once I get on up to 6, I actually get larger than 40 in this case. Right, I'm just making a list of the perfect squares. Now, what I want to look at here with 40, is there a way that I can factor 40? Is there a factor of 40 that is a perfect square? That's probably the best way to say it. All right, so is there a number off of this list that goes into 40? And if there is, I want to find the biggest one. And so we look, and of course 1 goes into 40, but that's kind of a boring result. But 4 goes into 40. And if you look, 9 doesn't go into 40, 16 won't go into 40, 25, 36, none of these go into 40 except for 4. So what we can do here is we can rewrite this as the square root of 4 times 10. All right, because 4 goes into 40 10 times. And now there's the thing about radicals that when you have a square root of 4 times 10, you can write that as the square root of 4 times the square root of 10. And so the square root of 4, I can simplify that now. That's why I wanted to find a factor that was a perfect square, because the square root of 4 can be written as 2. And now the square root of 10, you should always check here, is there any number over in this list that can go into 10, and none of those numbers can go into that. So we have simplified square root of 40 down into 2 square root of 10. All right, now we can take this one step further. Let's say we're given the problem square root of 6 times the square root of 10. And somebody wants us to simplify that. So if you start this process here, none of these numbers go into 6 or 10. All right, but what we can do first is put these together, and just like we saw here, if I can break up the square root of 4 times 10 into the square root of 4 times the square root of 10, I can also combine these and write this as the square root of 60. And what happens there, when I do square root of 60, I can come back to my list now and I can say which of these numbers over here will go into 60. And so now I can look, and once again 4 goes into 60. So I can write that as, now break it up into the square root of 4 times 15. Alright, so I can write that as square root of 4 times the square root of 15. And therefore, likewise, I can do square root of 4 is 2. And then square root of 15, again, just double check to make sure you did get the biggest factor here. Is there any of these numbers that go into 15? And there are not. All right, so let's do another example, and I'm going to take it one step further now, and I'm going to introduce the idea of complex numbers. What if this was the square root of negative 6 times the square root of negative 10? Okay, use those exact same numbers, and I'll show you what happens here. Now, let's recall that when we start talking about complex numbers, I is defined as the square root of negative 1, and this is the way we deal with having a negative inside of a radical, because this is an impossibility. A square root of negative 10 says, what number do I multiply by itself to get a negative? And you cannot multiply any number by itself, positive or negative, and get a negative. You will always get a positive, and that's why we have this notation here of I. So what I'm going to do here is I'm going to break this up into the square root of negative 1 times 6 and the square root of negative 1 times 10. And when I do that, I can write that as the square root of negative 1 times the square root of 6 times the square root of negative 1 times the square root of 10. And now I've broken it up into 4 things. And so this square root of negative 1, I can represent that with I, square root of 6, times I, square root of 10. Okay? And now what we have here is we have an I and we have another I, and we've just again changed square root of negative 1 to be represented by I. So I'm going to take I times I, and I get, in this case, I squared. All right, and times square root of 6 times the square root of 10. And so I squared is square root of negative 1 times the square root of negative 1. And hopefully you realize, for example, I'm just going to make up a thing here. Square root of 37 times the square root of 37. Hopefully you realize you don't need to multiply 37 times 37 and then take that square root. If you're multiplying the square root of something by itself, this is just 37. It's the thing that's in the radical. If you multiply a square root by itself, it's just the thing inside the radical. So if you multiply square root of negative 1 times the square root of negative 1, you get that squared is just negative 1. And so now that's turned this problem into -1 times the square root of 6 times the square root of 10, or just negative square root of 6 square root of 10. And as we saw earlier, we can simplify square root of 6 square root of 10 into square root of 60, which then turns back into -2 square root of 15. All right, so hopefully this little video shows you a little bit about how to simplify radicals at a basic level, and then a product of radicals can be simplified in a similar method. And then from there we can introduce these ideas of complex numbers and solve it from there. So hopefully this answers your question, and let me know if you need any more help with this.